Hi, Dr. P here, and in this lecture I'm going to start talking about synthesis. And we'll start out looking at some quote-unquote simple synthesis first. So when you are, let's say, building a house or some other kind of construction project, you must have the right tools. But you also need to know how to use those tools. And when you build a molecule, which is basically designing a synthesis, a lot of tools are available. Now, what are these tools that are available? Well, they are the reactions that we've encountered. Now, we need to know how these reactions work, which is why we do some analysis of mechanism and stuff. Just as an example here, I'll ask the question, what tools, and here our tools are going to be reagents and conditions, are needed for the following synthesis. Okay, so what we'd want to do is go back and look at reactions that you've seen. So if you have like the table of alkene reactions, so we'll say look at reactions we've seen. Table of alkene reactions, table of alkyne reactions. And then I'm actually going to provide another PDF. So we'll say list of reactions from Ms. Gibson, PDF to be posted. So you can look at that PDF, and it's got basically all the reactions that we have looked at and will look at this this semester. And that includes stuff that's in Chapter 17, which we'll be getting to soon. So when we look at these reactions, we see that, yes, we do have a reaction that will convert an alkene to the dibromide. Okay, so we could use, so to do this, we're going to use Br2 in CH2Cl2. So, you probably want to write in the solvent here, but it's not crucial. The important part here is Br2. Now, of course, you'll want to practice this. So let's take a look then at how you should go about maybe working on some practice problems. Okay, if we're going to try to solve a one-step synthesis, we want to look at the structures of the reactant and product. We want to take a look at how functional groups have changed. And then you'll want to use the reactions and mechanisms that you've learned to determine the appropriate reagents and conditions. Now, I should say that for a one-step synthesis, this is an awful lot like the fill in the blank for reagents and conditions. At the very end, you can check your answer. If you're brave and you feel like working out the mechanism. This part is optional, of course. I'm not going to make you do that. Again, another example here. How would we turn 1-methyl cyclohexene into 1-bromo-2-methyl cyclohexane? Now, we do have a reagent that would do this, so we will use HBr and ROOR. We'll use our peroxides because that's going to be anti-Markovnikov. Anti-Markovnikov. Okay. Let's take a closer look at transforming functional groups. Okay, now we actually know how to move a halide. So for example, I could take the following alkyl halide. I can do an elimination and I'll get that alkene, and then I can do an addition and I can get now the different alkyl halide or alkyl bromide with the bromine on a different carbon. So my bromine has moved over a carbon. And I did that by using two reactions. And so it's important to it's important to understand the regiochemistry of the reactions. And again, the table of alkene reactions and the table of alkyne reactions talk about regiochemistry, Markovnikov and anti-Markovnikov. We actually saw also in elimination, we could get a Zaitsev product or a Hofmann product. Those are regiochemical differences. Okay. So we actually have the ability to do something like, if we started with this guy, I could go ahead and do an elimination, and if I use NaOET, I will get my Zaitsev product, which is that guy there. If I wanted to go back to where I started, well, it's an anti-Markovnikov, so I'd have to use HBr and ROOR. But I could just add HBr and get the product I got up here. Now I have another elimination I could do. So let's use something like TBU OK or NaOTBU, something hindered. And that's going to give me my Hofmann product. Now, if I wanted to go back to where I started, sorry, my arrow's a little messy there, I would just use HBr because that's a Markovnikov addition. Or if I used HBr and peroxides, I would end up getting, I'll just draw it like that, Br, there we go. I'd end up getting the bromine on less substituted carbon at the end there. Okay, so I'm able to, within some limitations, move the bromine around. And, looking at this, gosh, if I treated this guy with, I could even treat this with TBUOK, and I would get boom, 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 like that. And now I could do HBr, ROOR, and I would get boom, 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 BR, like that. So I've even put it on a different carbon. So I've actually got 4 different carbons that I could move my, and these two end up being equivalent. But so I could actually move the bromine around to almost any carbon in this, or actually to any of the carbons in this molecule. So that's a pretty powerful thing. Okay, so it's definitely worth remembering regiochemistry. Okay, remember your Markovnikov and anti-Markovnikov. Remember your Zaitsev and your Hofmann. Now, the same thing will work with moving an OH. Okay, I could start with that alcohol, and then I could go ahead and do an elimination. Now, how should I do this elimination? Well, actually, the best thing to do is probably to use tosyl chloride and pyridine. That's just the solvent. And then, so that makes the tosylate. So once we have a good leaving group, we can treat it with NaOET, and that gives us our Zaitsev product. And then if I just use dilute H3O plus, I'd go ahead now and I'd end up getting my OH there. Or I could do oxymercuration, demercuration. That could work as well. If I wanted to go back this way, well, I need to do an anti-Markovnikov, so that is BH3.THF followed by H2O2 and NaOH, or OH minus. Now if I treated this guy with tosyl chloride, I'll just abbreviate pyridine with PY, and then I use my TBUOK here, my T-butoxide, I'll end up getting I'll get the Hoffman product. And so now I could go ahead and if I do my BH3.THF followed by peroxides and OH minus, I will get OH like that. And of course I could go back that way using my dilute. Actually, I don't want to use dilute H3O plus because I could get a rearrangement. The reason is I'd make a secondary carbocation and then that hydride could hop over. And so instead, I'd want to do my oxymercuration, demercuration. So let's do that. HgOAC2, H2O, followed by NaBH4. Okay. And I could actually, again, I could treat this guy here with TSCl and pyridine, and then 2 TBUOK, and I would get boom, 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 boom. And then that guy, then I could do 1 BH3.THF 2 H2O2 OH minus. And once again, I've moved it to the other one as well. So anyway, let's just kind of set that aside there. So we've got a variety of reactions, and we can kind of, depending on where you start, you can end up in a different place. So I could start with my OH on one end, and if I did an elimination, I would go back here, and then I could do my Markovnikov addition, and then do another elimination with the Zaitsev product, and then do a hydration, then a Hoffman elimination, and then anti-Markovnikov hydration. And now I've moved it to the other end of the OH to the other end of the molecule. Now, in reality, this is often more trouble than it's worth, because that was what if I do so that's one step, and really it's going to be 2 steps: tosyl chloride and then the base. But anyway, so 1, 2, 3, 4, 5, and that's 5 steps. 6 steps, sorry. 1, 2, 3, 4, 5, 6 steps. So that's a lot of steps just to do something like moving a functional group around. But we can do it. We can do the same thing, again, with some limitations for double bonds. So we can do it for alkenes, too. So let's say I had this guy, and I just added HBr. Now if I wanted to go back, I could use NaOET, because that gives me my Zaitsev product, or if I use my hindered base, I'd go ahead and end up getting my double bond moved over there. I could also instead do HBr and ROOR, use my peroxides here, and that's going to do anti-Markovnikov, so I'll end up with bromine there. Now, of course, doing NaOET just brings me back to where I started, but I could use my TBUOK to get my double bond moved there. Now, the problem is I'm not going to be able to move it over anymore, because if I try to brominate this, or not brominate, but add HBr, either side is, I get a mix of products. I get bromine adding to one side, hydrogen to the other, or hydrogen and bromine, because they're both equally substituted. So this is about as far as I can get here. But we can do things like this. Now, notice that I haven't mentioned stereochemistry. So stereochemistry is something that you may have to watch out for. Okay? All right. So let's see here. All right. Let me show another functional group transformation. So let's look at how we can change saturation. So remember in chapter 10, I know we didn't have a quiz on it, but we have radical bromination. And we'll do Br2 and H nu, and that will give us now that. Okay, bromine is selective enough that we can control it. It's going to go, we'll get one bromine on the most substituted carbon. So now I could take this and do an elimination and get an alkene. So I've gone from an alkene to an alkane. So I could, let's say, at one end here I'd have a CC triple bond, and then I could go to a CC double bond either by using H2 and Lindlar's or Na and NH3 liquid. And we've seen in chapter, we saw in chapter 9 that we can convert an alkene into an alkyne by first brominating Br2. So that gives me two bromines, and then I can do my NaNH2 and heat, for example, followed by water. But I also have a way to go from a CC double bond to a CC single bond, which is just H2 and platinum. That would actually take me from a triple bond all the way to the single bond as well. But using this reaction up here, I can, so Br2 and H nu, followed by NaOET. I'll introduce a bromine, and then now that I've got that leaving group, I can go ahead and do an elimination. So we can change our double and triple bonds around some as well. So let's take a look. We'll do maybe one more example here. Actually, this video is running on a little long, so I think I'll do more examples in subsequent videos. So the next video I'm going to talk about changing carbon skeletons and then planning multi-step or more complex syntheses. And we'll talk about, and I know I've mentioned this a little bit in class, but we'll talk about retrosynthesis. All right. Well, until then, stay safe out there. Bye now.